And I heard something said one day that I thought was actually really silly, which was our safety systems will protect us. That'll keep us from being hacked. And this is after I'd spent quite a bit of time going after these devices and knew better. So failure modes for industrial control systems that we want to keep an eye on, okay? These are 4 categories of the ways the plants go down. So ideally, one of the questions I ask on plant assessments, one of the first questions I ask is, what does your planned versus unplanned downtime window look like? What do your planned versus unplanned ratio look like? And when I see a company or I go into a customer that has a very high amount of unplanned downtime, that's the first indicator to me that they probably have mechanical integrity issues within the facility. So how is this managed? Safety on the whole combines physical infrastructures and safeguards, okay? Process control logic, what we call soft interlocks, right? So a soft interlock would be an example. In your PLC says if temperature sensor is greater than 200, then you want to reduce the burner or something like that. Or if machine speed is greater than some speed, you want to reduce the machine speed. And soft interlocks, it's just like changing logic in the PLC. If I can download the program and change it, I can change it myself. Changing set points, masking signals. And soft interlocks, if you really are using those and you have a truly dangerous process, you need to start thinking about upgrading that to another SIS. The risk equation, risk is what? Risk equals likelihood times consequence, right? We're dealing with the same consequences from a worst case scenario perspective. It's the likelihood component that's different, right? So in safety, they're just going to measure, here's how often it's going to happen. In security, we're saying, here's how likely it is that I'm going to make it happen. And I run into a lot of places, here's the next rock, I run into a lot of places that put the safety builder and the engineering workstation on the same computer. You are giving the keys of the kingdom to somebody. Now, they have the ability to modify the safety instrumented function, and they have the ability to modify the process itself. Now, the interesting part, though, too, is I remind people with the safety systems, all you have to do is disable its functionality or give it a new tolerance, and then all you have to do is just wait. You don't actually have to hack the process. You just have to wait for an unsafe condition to occur. But what we did find, and we found it in this study, and what we found in things later, of course, was if I can get a hold of the firmware of the SIS, and pull that firmware off the device, which I was able to force some debug ports open on some of those, pull the firmware off, and then put the firmware back on. And at that point, all it is reverse engineering programming exercise. Pull the firmware off, change it yourself, put it back on, you can bypass the safety system that way, right? Or get a hold of the safety builder. Get a hold of the safety builder, make the change there if you want, and then write it back. So in other words, from a cybersecurity standpoint in safety instrumented systems, the 2 main avenues of approach are going after the safety builder or going after the firmware of the device, both of which were actually implemented in Trices. Okay? So to some level were implemented in Trices. So there's one of the reasons we really don't want you integrating these components. Now, I know there's some vendors that are doing it. We can have that discussion offline. I'm not calling anybody out now. There's different ways to do it. Okay?